Okay. So this is the last thing that we are going to do, and this is something again that is very, very important for the discussions that we are going to do from our next class onwards on interference, and that is something known as coherence. Okay. So when there are several sources of light or any other wave, and the waves are propagating in a certain direction, now ideal situation is that these waves are moving all, in harmony. They are moving in a harmonic fashion, all synchronized with each other. All right. However, usually that is not the case. So as I have shown you these two pictures here, see, this is the first picture. In the first picture, I'll define what coherence is later on. First, let us just look at the pictures. See, in the first picture, there are several waves. Okay. So they are all starting from this point. They are all starting at the same point with the same phase. See, they are all starting with the same phase, all going upwards. The profile for all the waves, 7 waves, are going upwards. But then as they move forward, they are all falling out of phase with each other. Can you see that? I have used different colors. So you can see that they are all falling out of phase with each other. There is no, fixed phase relationship between the waves as they move forward. It's not that this wave has a certain fixed relation with this or this. As you are moving forward in time, the phase relation between the different waves, they are absolutely haphazard. There is no relation as that you can speak of. Whereas in the second picture, again we have 7 waves coming out from the same at the same time, in the same manner, and we can see that even as they propagate forward in time and space, the phase relation between them is a constant. Okay. So say if you consider this front over here, this maroon front, then all of them are at the crest. So even after propagating, they remain at the crest. And they remain at the crest, right? If you take any intermediate point on the waves, you will see that as the waves propagate, the intermediate points also remain at a fixed phase relationship with each other. So they don't fall out of phase. There is a fixed relationship between the phases of the different waves as they move forward. So as you can see, this kind of a condition where they start together with the same phase, but with propagation of time and space, they fall out of phase. They are called incoherent light waves. Whereas if there is a fixed phase relationship between them, even as they propagate forward, they are called coherent light waves. Okay. So a wave is said to be perfectly coherent if it appears to be purely sinusoidal for an infinite period of time or in infinitely extended space. There is no change in its sinusoidal nature. Then it is said to be perfectly coherent. Now we are more bothered about 2 sources. Okay. So what happens if there are 2 sources of light? If there are 2 sources of waves, then the 2 sources are called coherent. The waves will not be coherent. It is the sources that will be coherent or incoherent. Now 2 sources will be called coherent if they produce waves that have a constant phase relationship. Okay. So this constant phase relationship is very important. If they have a constant phase relationship, the same frequency and waveform. So you can understand what is the difference between these 2 pictures. For example, I have taken some examples which will make this thing clear to you. Hopefully, that's my intention. See, here you can see in this picture some soldiers marching forward. Okay, if you carefully look at their feet, I have only shown their feet here. If you carefully look at their feet, you can see that all of them have their right foot forward. Okay, heels touching the ground and feet upwards. Correct? And if you take a look at this entire group of soldiers, you will see the same thing. All of them have their right foot forward, almost same gap between the right and the left feet, and all of them have their heels touching the ground and their toes upward. So this is what I mean by perfect coherence. And even as the soldiers march forward, when they all put their left foot forward, it will be the entire team having their left foot forward, and so on. So the entire team will simultaneously put their right foot forward or their left foot forward, and that will continue. That is the synchronization when we see the soldiers march. Okay, so that is called perfect coherence, meaning there is perfect synchronization. In the next picture, we see, this is probably the picture of a shopping mall, or it can be an airport or a railway station. I don't know. I've just taken this picture randomly from in the internet. And you can see that there are several people here, but none of them are in sync with each other. They are all moving here and there. Okay, so if you start your observation at t equal to 0 and then continue your observation, you will see that there is no synchronization between the movement of all these people. They're all moving here and there, different speeds, different directions, different postures, etc. So this is what I mean by total incoherence. All right. And finally, the last picture you see, again we have a group of people. This is some festival. I don't know from what kind of festival. Again, this is something I've taken from the internet. So again, you see they are all moving in a straight line, and some the girls are carrying something on their heads. The men behind, they are with umbrellas. But if you look carefully at the picture, they are all moving in the same direction. However, they are not in perfect synchronization with each other. This girl in front has her right foot forward, whereas the girl behind her has her left foot forward. The girl behind her has just lifted up her right foot, and so on and so forth. So they are moving in the same direction, but not in perfect synchronization. So this is what I mean by partial coherence. Okay. So do these three pictures explain to you what coherence is? Perfect, total, and partial. If you have any doubt, please unmute and tell me. I'll explain once again. Have I been able to explain what coherence is? Yes? No? Not sure? Any answer? No? Can someone unmute and tell me? Can you all hear me?
Yes, ma'am. Now we can hear.
You were not being able to hear so long?
No, ma'am. Just a few seconds ago, the network went berserk.
So did you hear what I said about coherence?
Yes, ma'am, absolutely.
Okay, thank you so much. Okay. So I hope the concept of, now there are book related, definitions and that you need to learn, and mathematical expressions that you need to learn related to coherence. But I thought that this pictorial way of showing what coherence means and what is the difference between perfect coherence, partial coherence, and total incoherence. I thought this would uh, make you understand it in such a way that learning up the, what should I say, the bookish definitions will not be a problem later on. So this is the understanding that I want you to have about coherence. Okay. So coherence, now that we have understood qualitatively what coherence is, now if someone asks you what coherence is, you can't say when soldiers march together in synchronization, that's coherence, and when a crowd walks here and there in a mall, that is incoherence. No, you can't say that possibly, right? That is what I showed you in order for you to understand the situation. Of course, when you have to define coherence, you have to say that when two or more sources produce waves that have a constant phase relation between them, then we say they are coherent. Now, coherence can be of two types: temporal coherence or spatial coherence, as you can understand from the names that it is either related to time or to space. What is temporal coherence? It tells us how monochromatic a source is. Okay, and it is a measure of the correlation of the light waves phase at different points along the direction of propagation. So if there is a delay, okay, over which the phase or amplitude and therefore the correlation decreases by a significant amount, then that is called coherence time. Suppose they start as coherent waves, but over time that coherence decreases. So that amount of time up to which it remains coherent is called coherence time, tau c. And the distance traversed by the wave in this time, tau c, is called coherence length. Okay. So these are two definitions that are important related to coherence. Coherence time, what is it? Just remember that suppose a wave train has started being coherent. However, after some time, after the lapse of a certain amount of time, the correlation between the different waves that diminishes or deteriorates. So the amount of time till which the correlation was there is called the coherence time, and the distance that the wave traverses in this time is called coherence length. Alright. So if a light is monochromatic, then of course it will have infinite coherence time because it is perfectly correlated with itself for all delays. If you consider white light, then it would be incoherent because there is a large number of frequencies, a large range of frequencies. Larger is the frequency range, faster is the deterioration of the coherence or the correlation, that is decorrelation. So if you have composite light, then larger the range of frequencies involved to make up that composite light, faster is the decorrelation, that is tau c decreases. You understand? Lesser is the time by which the waves go out of phase. Okay, maintaining the relation that tau c multiplied by delta f, that is range of frequency, equal to 1. So if delta f goes up, tau c goes down and vice versa. What is spatial coherence? It is a mutual,
বলবেন
হ্যাঁ বলো বলো,
কি জিনিস ডিকোরিলেশনটা একবার বলে দিন।
হ্যাঁ, ডিকোরিলেশন মানে হচ্ছে যে এই যে যেটা বললাম যে টাউ সি কি, হোয়াট ইজ কোহেরেন্স টাইম, যে ধরো একসাথে শুরু করলো ওয়েভগুলো কয়েকটা সোর্সের থেকে, তারা কোহেরেন্ট ওয়েভ, দে স্টার্ট অফ অ্যাজ কোহেরেন্ট ওয়েভ, কিন্তু with a মানে যত তুমি ডিলে, যত দূরে যাচ্ছ তুমি সোর্সের থেকে, তুমি দেখছো আস্তে আস্তে ওদের ফেজ রিলেশনটা ডিটোরিয়েট করে যাচ্ছে, কনস্ট্যান্ট ফেজ রিলেশনটা থাকছে না, তার মানে ডিকোরিলেট করে যাচ্ছে। এবার যত দূরে তুমি যাবে তত এই ডিকোরিলেশনটা বেশি হবে। তাহলে যে পয়েন্ট অফ টাইম অবধি কোনো ডিকোরিলেশন নেই তাকে তুমি বলছো কোহেরেন্স টাইম। হ্যাঁ, তাহলে মোনোক্রোম্যাটিক লাইট যদি হয়, তাহলে একটা সোর্স থেকে একটাই কালারের লাইট বেরোচ্ছে, তাহলে তার তো ল্যামডা ফ্রিকোয়েন্সি সব সেম, ভেলোসিটি সব সেম, তাহলে তো তার নিজের সাথে ডিকোরিলেট করার কোনো, there is no chance. So it will remain coherent for infinite time, which means monochromatic light এর coherence time হচ্ছে infinite. Ideal situation. Ideal monochromatic ও হয় না আর infinite coherence time ও হয় না। কিন্তু যদি আমি আইডিয়াল মোনোক্রোম্যাটিক সোর্স পেতাম তাহলে তার কোহেরেন্স টাইম হচ্ছে ইনফাইনাইট, ইনফাইনাইট টাইম অবধি তুমি কোহেরেন্স দেখতে পাবে। কিন্তু তুমি যদি হোয়াইট লাইট বা কম্পোজিট লাইট দেখো তাহলে দেয়ার ইজ আ রেঞ্জ অফ ফ্রিকোয়েন্সিজ ইনভলভ। যেই রেঞ্জ অফ ফ্রিকোয়েন্সিজ থাকবে, তুমি যত ডিলে টাইমটা বাড়াবে, যত বেশি টাইম পরে তুমি এই রেঞ্জ অফ এই ওয়েভগুলোকে দেখবে, দেখবে দে আর ফলিং আউট অফ ফেজ, দে আর গেটিং ডিকোরিলেটেড। তাহলে যত ফ্রিকোয়েন্সি রেঞ্জ হাই হবে, দ্য টাইম আফটার উইচ দ্য ডিকোরিলেশন টেক্স প্লেস, মানে কোহেরেন্স টাইমটা কমে যাবে। যত ডেল্টা এফ ফ্রিকোয়েন্সি রেঞ্জ যত বাড়বে, তুমি আরো আগে ডিকোরিলেশন দেখতে পাবে। ধরো তুমি সোডিয়াম মের দুটো ওয়েভলেন্থ, যেটা সোডিয়াম D1 আর D2, 5896 অ্যাংস্ট্রম আর 5890 অ্যাংস্ট্রম, এই দুটো দেখছো, তাহলে এই দুটো লাইটের ক্ষেত্রে তোমার কোহেরেন্স টাইম যত হবে, তুমি যদি তার সাথে তুমি যদি কম্পেয়ার করো হোয়াইট লাইট, যেখানে সাতটাই প্রাইমারি সাতটা ওয়েভলেন্থই আছে বা সাতটা ফ্রিকোয়েন্সি আছে, তাহলে দেখবে তাদের টাউসি অনেক কম সোডিয়াম D1 D2 টাউসি এর থেকে। তার মানে কি অনেক আগে এই ফেজ রিলেশনটা নষ্ট হয়ে যাচ্ছে। ওকে, so which means that tau c and delta f are reciprocal to each other. tau c যদি বেড়ে যায় তার মানে ডেল্টা এফ কমে যাচ্ছে, ডেল্টা এফ কমে যাচ্ছে মানে কি রেঞ্জ অফ ফ্রিকোয়েন্সি কমে যাচ্ছে। tau c ইনফাইনাইট মানে ডেল্টা এফ জিরো, delta f 0 মানে it's a monochromatic light. Clear? Is it clear now?
Yes, madam.
Okay. And the second kind of coherence is spatial coherence. This is a mutual interdependence or connection of variable wave quantities of two different points at the same instant of time. তুমি দুটো ওয়েভ নিলে, তাতে দুটো ডিফারেন্ট পয়েন্ট at the same instant of time নিলে তাদের মধ্যে যে রিলেশনটা, so it gives the phase relationship between the radiation field at different points in space. The range of separation between 2 points over which there is significant interference defines the diameter of the coherent area. মানে কত দূর অবধি তুমি একটা সার্কেল টানলে তুমি দেখবে যে ওইটুকুর মধ্যে ফেজ রিলেশনটা কনস্ট্যান্ট। তার মানে আমি এই ছবিটার কথা বলছি, এই যে এই ছবিটার কথা, যে কত দূর অবধি নিলে এখানে তুমি দেখবে যে ফেজ রিলেশনটা কনস্ট্যান্ট। এটা হচ্ছে এইখানে যেটা আমি দেখতে পাচ্ছি পারফেক্টলি কোহেরেন্ট, তার মানে হতে পারে এর পরে ইনকোহেরেন্স সেট করছে, তাহলে দিস ইজ দ্য কোহেরেন্স টাইম। এবার এই এরিয়াটা টানলে, এখানে এই ডায়ামিটারের এরিয়া টানলে তুমি দেখবে যে ইট ইজ কোহেরেন্ট উইদিন দিস, সো দ্যাট ইজ স্পেশিয়াল কোহেরেন্স। Relationship between 2 points, two different points at the same instant of time. You are when you are talking of temporal coherence, you are looking at the wave at different instants of time. কতক্ষণ পরে দেখছো তার উপর ডিপেন্ড করছে কতটা ডিকোরিলেশন হয়েছে। স্পেশাল কোহেরেন্স হচ্ছে you are looking at two different points at the same point of time. If there is a constant phase relation, then there is spatial coherence. If they are out of phase and they go further out of phase, then there is no spatial coherence, and that is determined by a parameter called coherent area. Okay, so AC is given by this relation. d square lambda square by tau by pi d square, where small d is the diameter of the source and capital D is the distance of the source. Okay. So as you can see that when you're further away from the source, as you go further away from the source, your area of coherence increases, and as you decrease the diameter of the source, the area of coherence increases, also with lambda. But this is actually for a given lambda what happens. Okay. So these are the two concepts related to spatial and temporal coherence that you need to know, and you'll be seeing in our next class onwards why I made these definitions of wavefront, the concept of Huygens principles, and the concept of coherence so detailed. কেন এত ডিটেইলে আমি এটা ডিসকাস করলাম সেটা দেখতে পাবে, because at every point of time we are going to refer to this Huygens principles, coherence and wavefront. Okay. That's more or less what I wanted to discuss in wave nature of light. So with this